A pipe made of super-invar with both ends open has a mean tone of 262 Hz when air is blown over the top. If the thermal expansion of the super-invar pipe is negligible, which of the following changes can be caused by the increase in temperature in the room? 1. Speed of sound in the pipe increases. 2. Frequency of the main tone increases. 3. Wavelength of the main tone increases. The speed of sound in a gas depends on the root mean square speed of the gas. So, when the temperature increases, the root mean square speed in the gas increases. That means the speed of sound in that gas would increase. So, number 1 is right. Now, let's look at the frequency and the wavelength. We know that speed equals to frequency times the wavelength, and the wave speed is going to increase, but how the frequency changes will depend on the wavelength in this case. Let's see, we have organ pipe that has a fixed length because the thermal expansion of the pipe is negligible. At the fundamental frequency, there's a certain number of loops that can be fit inside the pipe. So if the length of the pipe stays the same, that means the length of the loop stays the same, and that means the wavelength stays the same. So if the wavelength stays the same, then the frequency must increase because the speed of the wave increases. So number 2 is right, but not number 3. So the answer is 1 and 2 only, C. Car A and car B have identical horns that emit the same frequency sound. Both cars are sounding their horns as they travel away from the observer. At a certain moment, the observer hears a higher frequency horn sound from car A than from car B. Which of the following must be true about car A at that moment? 1. It is traveling at a slower speed than car B. 2. It is closer to the observer than car B. 3. It has a higher acceleration than car B. The frequency shift can be explained by Doppler effect. In this case, the wave source, the horns, are moving away from the observer. So the observer sees wavelengths that's longer than the wavelength produced by a horn that is stationary. Because the sound wave is still traveling through the same air, so the speed of the sound wave stays the same. That means if the wavelength gets longer, the frequency must shift lower. Because both car A and B move away from the observer, so the horn sound from both cars should shift lower. Now, the faster the car, the more the shift. The slower the car, the less the shift. Since the observed frequency for car A is higher, that means the frequency did not shift as low as car B's. That means car A must be slower. So the answer is A, 1 only. Number 2 is wrong because the amount of Doppler shift only has to do with the velocity of the wave source and the velocity of the observer, if the observer is moving. It has nothing to do with the distance between the observer and the wave source. Number 3 is also wrong because, again, the amount of Doppler shift depends on the velocity, not the acceleration.